So in this problem, we have a spray boom with 10 nozzles spaced 20 inches apart, and we're calibrating this sprayer using the time volume method, where we're collecting the water from each of the nozzles. And then it says we have a plan to spray pesticides at 8 miles per hour. And so with any calibration problem, our goal is to get, in this particular case, gallons per acre. But in all cases, we want to eventually get to volume per unit area. And so that's what we really have to start with, is volume per unit area. And so part A of this question is starting us down this path of trying to get to the area. And so the question is, what distance would you travel during the time of the calibration run? And so this isn't actually specified in this problem. And so it's important to keep in mind that, it's going to give us the hints of what we need to get there, because it gives us both the time, which is 1 minute, and it also gives us the speed that we are assuming to be traveling. And so we can derive then the distance that we would travel during this run with these two pieces of information. And so again, starting with what we know that we are supposed to be traveling at 8 miles per hour. Okay, and we also know that our calibration run lasted 1 minute. And so that's actually fairly straightforward for this one. So one of the nice things about doing 1 minute is we can actually calculate that directly by converting 1 hour is 60 minutes. Okay, so that then will convert our miles per hour into miles per minute, because our hours will cancel out. So that will give us miles per minute. In general, though, when we're talking distances and swath widths, it's easiest to standardize on feet, especially when we're trying to get to gallons per acre, because then we're going to be talking about square feet. And so if we want to convert this into feet, then we need one more unit conversion, and that is 1 mile. And again, we put that in the denominator so that we can cross out the units with the 8 miles per hour. And 1 mile is 5,280 feet. And if we multiply that all through, we end up with 8 times 5,280 divided by 60. And the units, because again we canceled out miles, we're going to be left with feet per minute. And that gives us 704 feet per minute. And again, because our calibration run was 1 minute, then this is actually our answer to part 1A. Okay, so part B, what is the sprayer swath width? So the swath width is calculated simply by taking the number of nozzles, which is 10 nozzles, and the distance they are from each other. So they're spaced 20 inches apart. So our swath width then is going to be 10 nozzles times 20 inches, or 200 inches. But again, it's usually easiest to work in feet, and so we want to actually divide that by 12 in order to get feet, and that's going to give us 16.67 feet. And this is going to be the answer to part B. Either one would technically be acceptable since it didn't ask for the units. But because we're going to be talking about these in feet, it tends to be easier to say the swath width is going to be 16.67 feet. And then what I typically like to do when I'm doing these calibrations is, because the next question is going to be actually the final answer, which is the sprayer output in gallons per acre. So I actually like to just draw myself a little diagram to kind of help me visualize what's going on here. And so if we actually look at this as an area, because again, we're wanting to get volume per area, we know that our theoretical calibration run length is 704 feet. And we know that our swath width is 16.67. And that then, if we know the length and the width of the area, that means we can calculate the area. And if you take 704 times 16.666667, then that gives us an area of 11,733 square feet. So that is the area that we're actually looking for. And so again, we want to get volume per area. So that means we need to figure out what the volume is. And so during this calibration run, we collected an average of 21 fluid ounces of water from each nozzle. And we have 10 nozzles, which means to get the total volume, we would actually take 21 fluid ounces times 10 nozzles to get the total amount that was coming out of the entire boom. So 21 fluid ounces times 10 equals 210 fluid ounces. And that's going to be our volume that we can then do unit conversions to actually get to gallons per acre. And so I usually write that right here, 210 fluid ounces. So this then has almost all of the information we need to end up getting to our final answer of gallons per acre. So it gives us a volume, and it gives us an area. And then all we have to do is do unit conversions to actually get to gallons per acre. So if we actually run through that calculation, we can do 210 fluid ounces were applied to an area of 11,733 square feet. And then again, we do unit conversions, so we want to get to gallons, and so we'll do 1 gallon is equal to 128 fluid ounces, which then cancels that unit out. And then we also want to convert square feet to acres, and so 43,560 square feet is 1 acre. And so if we actually calculate all of that out, we get big numbers in both the numerator and the denominator. 600 gallons divided by 1501824 acres. And so if you divide those two numbers, you end up getting 6.1 gallons per acre, which we usually specify as just GPA.